In this lecture, we'll talk about networking libraries. Now, we've already talked about socket library in previous modules, but we're going to go into other libraries just a little bit, and then we'll get to specific sort of vendor-specific libraries that allow you to communicate with different services online. So, networking libraries. We've already learned about the socket library. A socket library is a very low-level library. Okay, by that I mean there's it's very useful, but there's more work for the programmer to do. Meaning the programmer is left to handle a relatively large amount of details when it comes to using a socket library to send a message. So specifically, the programmer has to compose the message content. So that means that the programmer has to be aware of what the network protocol defines as the message to look like. So the programmer has to know, well, for HTTP, you got to have this line with the method at the top, and then this on the second line. You got to have a series of headers. You got to know what the valid header values are. You have to know a decent amount about what the message is supposed to look like in order to use the socket library, because with the socket library, you have to specify that as a programmer. Now, sometimes, socket library is good if you're just making some sort of ad hoc communication. Say I just want my Raspberry Pi to connect to my other Raspberry Pi, right? And then when I want them to talk to each other, I can use whatever protocol I want. I don't have to use HTTP or any specific complicated protocol. I can just make up something. I can say, look, I'm going to send 10 bytes every time, which are the results from my A to D converter, something like that. Or actually, a Raspberry Pi doesn't have that, but results from my computation. If I know that, then a socket is good because you don't need any particular kind of protocol that you have to worry about. You just stick 10 bytes on the wire, and at the receiving end you receive 10 bytes, and it's very simple, right? There's no protocol you have to worry about because you can make up the protocol and make sure it's simple. But with more complicated protocols, it becomes a little bit more work to use the socket library because you have to compose the message. So you have to know the details of the protocol. So here's an example, and actually we saw this example several lectures ago. This is, sorry about the indentation, it's just hard to fit on the screen right, but the indentation, and the indentation is important with Python. But what's happened here is that some of these lines are broken up over several lines. So for instance, the first 3 lines you see on the screen, that's one line. Okay, that's the creation of the socket. Actually, we did this example before. All this is doing is connecting to google.com and sending it an HTTP GET message. So basically requesting the website, requesting the data on the website, the HTML on the website. So you can see we're calling socket to create the socket. Then socket.getHostByName with google.com. So we have to get the host, the IP address for google.com. So that's doing a DNS lookup. And then after that, you do a connect. And then notice it says message equals, and we have that message in quotes, get blah, 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 and then we send. Now, the thing to notice about this is that that message, you had to compose that message. Now, this is a very simple message, but you had to know protocol-specific details to know what that message should look like. The fact that the word get has to be the first thing you see, get or put or something like that. There are several headers that have to be first, and you have to know that about HTTP rather, in order to make that message. The next thing, that's slash, that's telling you what directory to look at, what a file to find, right? So slash is just saying, look, whatever file, the index at the top level, that's what I want you to get, right? You have to know that. HTTP/1.1, that's giving you the HTTP version that's being used. You have to put that there, and you as a programmer have to know that. Also the /r/n/r/n, that's the character return line feeds, a couple of character return line feeds that you need, right? You need 2 of them to let it know that that's the end of the message. So those details, I mean, I know about those, but we didn't specifically talk about those, but it's possible for you to look those things up. You can Google HTTP, find all the details. But it can be a pain, right? Because that's the most simple message you're ever going to see, HTTP message. They get longer. There are headers and more complicated things that you want to add into these type of messages. So using the bare socket library can be tedious for a programmer because they have to worry about all those details. It is nice sometimes to use protocol-specific libraries, and there are several of these available in Python and for the Raspberry Pi and so forth. And so these libraries, you have a lot of these just for one protocol. Now the programmer doesn't have to know the protocol details in this case. So they can just rely on these library functions that are available that handle the details. Okay, so it handles, for instance, the character return line feeds. It'll put those in, and it'll put them in the right place in the message and things like this, right? So you just call these functions that where the arguments of the functions are the key detail, the key information that you want to put in this message, and then the library function just composes it into the appropriate type of string of data, series of data, and then sends that for you. And then on the other end, it receives it. It does the same thing on receipt. So they'll have library functions that maybe receive a message of a particular type, and rather than showing you the whole raw message, they pull out the important things, you know, the payload and so forth that you're interested in, and strip away the rest, and you don't have to see that as a programmer. So using these application-specific, or rather protocol-specific libraries can be very helpful sometimes and make it a lot easier. So one of these libraries called, well, there's the HTTP library, right? And so you can import HTTP client, and then if you want to send that same GET message, you say con equals, you call this function, they provide you an HTTP lib called HTTP connection, right? So you call that function, and you just give it the name of the domain that you want to go to. So this actually does a DNS lookup, but it also establishes a connection. It rolls it up into one function. And then con request, get, and then slash, that is what actually sends the request message. So notice that you're just giving the key details. You're saying, look, get, this is what I want to do. This is the type of header I want. And then slash, that's the directory, the file that I want. You just give those key details, and it composes the bytes that it needs to send in the request. And this actually sends the request for you. So this makes it easier. Now, this isn't the difference between this and what we saw on the last slide isn't that big, because the thing on the last slide was pretty simple as it was. But this can be very helpful for more complicated types of messages. So even here, you don't have to worry about exactly how the data is going to be arranged in the packet, in the message, in the headers. You just give it the key data, the get and the slash, and it composes the rest. So protocol-specific libraries are very helpful in that way. And there are a lot of them for lots of different protocols, and we won't go through all those, but you should know this for future, like for the capstone, say, when you want your Raspberry Pi to interact with something on the network, you don't necessarily have to work from scratch with socket library and learn a whole protocol, right? Say you want your HTTP, you want your Raspberry Pi to talk to, not HTTP, let's say another protocol. Let's say you want it to talk to a mail server. You want to send some mail, for instance, okay? Send email. So email, the typical protocol is called SMTP. So if you want to send mail, you have to compose that mail and then make a message in the format of SMTP, defined by that protocol. Now, you don't know that protocol. Now, you can look up that protocol. You can Google SMTP and find all the information about what that protocol looks like. But an easier way is just to import SMTP lib, and then use the functions that are provided in there to send the email. It makes it much easier, right? So just remember that for the future. You don't want to have to build everything from scratch if you can help it. You'd like to, if there's any protocol, there's no way we can go through all the different protocols there are, but the different networking protocols at the application level. But look for protocol-specific, application-level protocol-specific libraries for any particular protocol that you're going to interact with your Raspberry Pi. So, along those lines, let's talk about how you interact with an online service. So what we mean by this is, say there's, okay, so Raspberry Pi, it's a nice little machine, but it's small, it's relatively small, okay? It only has so much compute power, it only has so much resources, so much information, right? So in order to get interesting things going on, you're gonna need, depending on what you want to do, you might need your Raspberry Pi to connect to the cloud, the web in general, or the cloud, and offload some of its job to the cloud, or get information from the cloud, right? So what happens is, the way this works is there are these online services. These services already out there on the web that do something for you, okay? That do some task for you. And maybe it's a computational task that your Raspberry Pi can't do fast or something like that. Or maybe it's accessing data that your Raspberry Pi doesn't have locally. So these services, they allow your machine to connect to them. So you can make a request. You send a message from your, say, Raspberry Pi to their servers with some kind of a request in there. Please give me this data. Please perform this operation, something like that. And then the server sends back a message to your device with the results. So there are a lot of online services like this, a whole lot, and they're pretty interesting to use. So, for instance, Google Maps, right? say you want to make a web page and you want to have a Google map in there. Say I want to have a web page with my office in there, direct people to my office or something, and I want to have a Google Maps site, a map in there with my address highlighted, my location highlighted, and directions to my house or whatever, my office. So something like that, I would make a web page, and I might want to have code that interacts with Google Maps, that allows people to do searches. Basically, what you would do on Google Maps, you could do it through my page. So there's an interface for that. There's an online service, and you can send it a message, a request message, send Google servers a request message, please give me this map and give me these directions, whatever, and it'll send them back, and then you can put them on your web page. Twitter. So say you want to send a tweet, right? You can write a program that sends a tweet. That you don't have to do it manually. It can create a message, send a message to Twitter servers take it and send the tweet. Or the other way, maybe you want your code to examine tweets, right? So you can send a request message, let me see tweets like this, and it'll send back the tweets. Let me see tweets that match this characteristic, and the Twitter servers will send them back to your machine. YouTube, maybe you want to make a web page or something like that, an app that has an interface that lets you upload videos, right? Basically, you can copy a lot of what YouTube already provides. You can put that locally on your device, on your app or your web page or something like that using their interface. And Facebook too, same thing, right? You want to look at somebody's profile, something like that through Facebook, you can write code that does that. Okay, and it's always Facebook servers or YouTube servers, Twitter servers, Google Maps servers that are doing the job, but your device is interacting with their servers through messages that are going back and forth. So there are lots of online services, and if you're interested, you can Google these type of web-based, usually they're called APIs. We'll talk about this. You can Google them and get a long list of lots of different public APIs that you can use. So, and some of these services you may have to pay for, right? They're not all free. Some of them, a lot of them, they have free parts, so maybe you get some abilities for free, but other things you have to pay for, right? So that depends on which service you're using, right? But some of them cost money. Thank you.